All right, welcome back to the first lesson, 22.5, solving nonlinear systems. So one of the first things they do in the Explore activities, they give us a lot of vocabulary. So it says a system of nonlinear equations. So nonlinear means one of them, if the equations might be not a line, is called a nonlinear system. And a system is just two equations. So there's two equations where one is a equation and one where it may be so this one would be linear, because you'll notice there's no exponent, or quadratic. Okay, but there's two of them, at least two. And the next thing they say is a system of equations in which at least one of the equations is nonlinear. So at least one of them, quadratic, just so you know, usually looks like an upside down U or a parabola, whereas a line, linear, kind of is in the name, looks like a line. And in a solution to that system is any ordered pair that makes all the equations true. You'll also see in the graph, let's say I had a graph, say I had my parabola, and let's say I had a line. So solution will be kind of where they cross. Also will make the equation true. So we're going to see what that looks like in a little bit visually. And we're also going to see in the next section what that looks like. What does it mean to make the equations true? Okay. Just a couple words you want to highlight. Just everything that we kind of went over. So here is an equation that's already done for us in your packet. So here they ask if this point is this ordered pair, which is this right here, is a solution for the system. So what I'll do is I'll go ahead and label X and Y, much like I already did here, right? And we're going to plug in, instead of X, we're going to replace it with 1. Instead of Y, we're going to replace it with 7. And we're going to work that out. They do it step by step. 1 plus 2 is 3. They then square that 3. And then they subtract, and they get 7 equals 7. This would be a true statement because 7 is equal to 7. Hence true, right? And so we're going to do that one more time with the second equation. So I'm going to copy that down. Y equals 5x plus 2. And let's go ahead and plug in, instead of x, we'll put 1. Instead of y, we'll put 7. Well, let's work this out. So that would be 5 times 1 is 5. And then if I add these together, that would be 7. Hey, I think that's true too. 7 is equal to 7. So in this case, both equations are true, which has to be the case for this point right here to be a solution. Yay. All right, let's see about doing this next one. So here they plug in, again, is this ordered pair a solution for this system of equations? So again, we're going to label X and Y. We're going to replace X with -1 and Y with -5. Also replace that X as well. We're going to go ahead and work this out. So that would be 1, -2, -4. And it looks like -5 is equal to -5. Let's see about this second equation. Y equals x plus 2. Again, we're going to replace x and y. And we're going to see if this works out. Is -1 plus 2 also -5? No, it is not true. It is false. Lies. So let's continue on where it says the second equation is false. So this point is not a solution. Oh no. So let's try a few of these that they want us to try out on our own. So here we'll plug in X and Y. So there's our ordered pair. Let's go ahead and write down the first equation. And we're going to replace each one of these variables with, here, I'm going to write that in for 1 and 3. I'm going to rewrite everything else. I can work this out. 3 take away 3 would be, I believe, 0 squared plus 1. Let's work this out further. 0 times 0 would be 0. And would this equal 1? It does! So that's a true statement. Let's continue on. So again, we'll replace y with 1 and x with 3. I'm going to rewrite everything else, the equal sign, the negative, and the plus 4. And let's see if this works out to be a positive 1 as well. It is true, so that means that this would be a solution. Yes, it's a solution. We got 2 trues. Let's move on to the next one. So again, for 2, let's go ahead and label x and y. As you can see, I did that already. Let's go ahead and write down our first equation. And we will write down our second equation second. So again, I'll go ahead and plug in, instead of y, we'll put in 2. Instead of x, we'll put in 4. Instead of x, we'll put in 4. I'm going to rewrite everything else. Alright, and let's work this out. So 4 squared would be 16. That would be negative 24 plus 10 equals 2. You can always calculate this out from here and work that out. And that would be 2 equals 2. Awesome. So that's a true statement. Let's try again that second equation, see if it works. So instead of y, we'll put in 2. Instead of x, we'll put in 4. And let's see what this works out to be. 2 equals, what would that be? 0. Oh no, that's not true, is it? 2 is not equal to 0. That would be false. So that means that, fortunately, 4, 2 is not a solution. All right, let's try the next one. Pause right here if you want to try this out on your own. And unpause, that would be, we'll label this x and y. That would be y equals x squared minus 6x plus 14. We're going to again write in our values for x and our value for y. And we're going to work this out. So that would be 6 equals 2 squared would be 4 minus 12 plus 14. So we can work that out and see if 6 is equal to, what would that be? 6. Awesome. All right. So let's continue on, because that's true. So we'll try the second equation this time. So instead of y, we'll put in 6. Instead of x, we'll put in 2. Write in the 2 that's in front of it, parentheses, plus 2. Let's work this out. So that would be 6 equals, what would 2 times 2 be? 4. And 4 plus 2 would be 6. So that is true, both true. So that way, both of those are true. So yes, this is a solution. Let's try the next one. Yes, I'm giving it away. It is going to not be a solution, but go ahead and just work this out. Try it out. Maybe I'm wrong. All right, label x and y. So that would be, instead of y and x, we'll write in instead 5 and 3. All right, let's work that out. 3 take away 3 would be 0. And then 0 times 0 would be 0. And would 5 equal 5? Well, that is a 5, so that is true. Let's go ahead and write, instead of y and x, let's write in 5 and 3. And let's work this out. So 2 times 3 would be 6 plus 2 equals 5. Now, is 5 equal to whatever 6 plus 2 is? No, so that is false. So of course this is not a solution. So I was correct in that. All right, we're going to continue on with explain 1, where it says solving a system of linear quadratic equations graphically. So that's that visual I was talking to you about for each one. If they do not cross, so there's no crossing, there's no intersection at all, that would be no solution. If they do cross, as I can see here, that would be one solution. And if they cross twice, that graph and this line, that would be two solutions. So in the example, they give us two equations, and they give us a table of values. This is the easiest way to graph, creating a table of values and graphing your points. So here we wrote in 5, 3. I'm sorry, 1, 5, 1, 5, 2, 2, which is that point right there, 3, 1, 4, 2, and 5, 5. I know it's already graphed, but still kind of nice to see that they still match. And then 1, 3, 2, 2. Hey, that's a solution, so they both have that. So, and then, sorry, last but not least, 3, 1. 3, 1. Hey, that's also another solution. 4, 0. 4, 0. And 5, 1. So as you can see here, they do cross in two places. They cross at 2, 2 and 3, 1. Alright, so now we're going to create our table of values. The way we did this in class is we can use a graphing calculator, or we can use Desmos. On the next video, we'll go over how to use Desmos to create a table of values. Okay, see you on the next video.